Hi, my name is Ankit Oja, and I'm recording this video for the requirement of my data mining assignment. So the goal of this assignment is to use PyCaret, a low-code machine learning library, to perform various data mining tasks and demonstrate them in Google Colab. So basically, like in this I'm creating the collab for the classification. So first one is like binary classification, and which is to predict like if a customer will churn or not, or other one is like multi-class classification. So a multi-class classification is like classifying images into multiple categories. So this is all like we are going to perform in this collab. So like this collab is especially for multi-class classification. So basically we are importing necessary libraries and installing the PyCaret here, and we will come down, and here we are checking the installed version of the PyCaret, and here I am loading the data set from the PyCaret. In this my case I installed like I data diabetes data set I used, and here we are uh, importing the PyCaret classification, and we are doing the initial setup. So yeah, so basically we are like here we are doing create a we are creating a classification experiment object, and then we are initializing the experiment object, and then like we are comparing different baseline classification models basically in this, and then like we are plotting the confusion matrix and like AUC like area under the curve. So all these things we are doing in this. So basically we are also plotting the feature importance for the best model. We are checking the available plots for their description. So all these steps we are doing in this and we are also evaluating the performance of the best model, and like we are predicting like using the best model on the holdout set. So this is also we are doing, and like we are creating a copy of the data without the target variable. So we are dropping the class variable in my case. So we are also predicting new data without the target value. So like I removed the class variable, and now without that data we are now like predicting. So we are now like after that we are saving the train data, and then we are saving the train data whatever we have saved, and then we are loading the save model, and then like after that we have assays and modify the PyCaret configurations. So basically all these steps we are doing in this collab. So we are we are comparing the models with a specific criteria. We are doing that, then we are training a specific model. We are customizing model training parameters. So basically we have trained and tuned a decision tree model. So and we have also customized the hyper parameter tuning. And this club was actually a little bit longer. So yeah, because we have done too much here. So we have also assembled models with bagging and boosting. Yeah, we have also plotted classification report. Yeah, so lots of things we done here. And we also created a Gradio application. Yeah, Gradio application also we have done here. So basically lots of things we have done. We have created REST API actually. We have also created a REST API. We actually created a Docker image, and then we finalized the best model for the deployment. We converted the model to other languages, and saving and loading the model actually. And then in the end actually, if lots of things actually we have done, I explained here everything. So here we are creating the app actually, Gradio app. Here we are creating, so all these things I explained you actually, everything I explained here. So all these steps I have done here. So in the end actually in the end actually we are in here in the end actually we are saving and loading the entire experiment. So this is all about this classification model. Hi, so now I'm starting this regression model. So here we are installing the PyCaret and dependencies, and we are checking the installed PyCaret versions. And now we come down below, and here we are checking what is the data in this data set, actually PyCaret data set. And then like I got this, I am using this Parkinson's data set actually. So we are loading the sample data set from PyCaret, and then like we are initializing the PyCaret regression model actually. Uh, and then we are comparing the different regression models below. We are comparing the different regression models. So this compares various regression models and identifies the best performing one based on default metrics. Okay, so like here, so here we are creating a specific model, like for in my case extra trees. So this creates an extra tree model. So we are now like we are plotting the model residual. Actually we are creating a light beam model, light GBM model actually, and then like we are plotting residuals and error for the light GBM errors, and then like we are plotting feature importance. Then we are evaluating the model. We are evaluating the model. We are predicting on the whole outset, and then displaying the prediction data frame actually. We have prepared a new data set for the prediction, and all these steps we have done here. So basically like if I have to explain you step by step, so this like we are comparing various regression model and find the best performing one, which is extra tree based on my default, some based on some default criteria. And then like we are creating the model. So it creates a model like extra trees and assesses it using visualization like the pseudo and error plots. And then we are checking the feature importance, like it analyzes the signification of different input features in the model performance. And we are and then like it gives a holistic evaluation of the model based on the various performance metrics. And then like in prediction wise, if we say that it uses the trained model to make predictions on new data points. One is a hold out data set automatically created by the PyCaret during the setup. So another one is like manually created one where target variable is removed to simulate a real world prediction scenarios. So yeah, all this we are doing in this regression model. So now I'm going to start this clustering. I'm going to explain this clustering collab actually. So I will give you the brief idea what we are going to do here. So basically like basically here like we are importing the necessary libraries first. Then we are installing the PyCaret with full dependencies actually. And then we are loading the data set. So it's actually loads the data set like in my case I can in my case actually it is diabetes. I choose the diabetes data set actually. And then like then after that we are setting the experiment actually. We created a k-means model actually. After that like here if you see that we created a k-means model. And then we are assigning a clusters to the data actually. Here we can see assigns the clusters to the data. And then we are plotting the cluster visualization. Then we are also plotting the elbow curve. Then like we are plotting different models there. And then like if we say that we are also evaluating the model. And we are then like making the prediction on the data set. So after that we are making the prediction actually on the data set. And then like we are saving the model. So all this like we are doing in this collab actually. So like basically like we installed the PyCaret and imported the necessary libraries here, loaded a data set and slices the clustering environment. And we created and trained the k-means clustering model and assigned cluster to the data set, and we sliced by the clusters. Finally we evaluated the model and made predictions and saved the trained model. So this is all we have done in this clustering collab actually. So basically, this all we have done. Now I'm like going to start with the anomaly detection collab. So here like first we are installing the PyCaret with full dependencies. So this command install the PyCaret library with all its dependencies. And then like we come down here, we will check like we are importing necessary libraries, whatever in there it is necessary. And then like we have also like used the session ID for reproducibility actually. And then like we come down here, we will check here. all these codes we have done. We are actually loading the anomaly data set, and then we are initializing PyCaret anomaly module, and then whereas if using anomaly experiment. So all these steps we are doing in this. So we are creating an isolation forest model here in this. So we are assigning the trained model to the data and get anomaly scores. This is the step by step. I'm telling you what we have done here. So we have evaluated the model using various metrics and plots. We predicted the anomalies for the data using the trained model. So then in the basically all these steps we have done here. So you can see. So in the end, in the end we saved the trained model and its pipeline. So here save model, actually this saves the trained isolation forest model and the entire pre-processing pipeline to the file named iForest pipeline. So this is all we are doing in this anomaly in this collab actually. Now I'm starting with association rule mining collab. So here basically first we have installed the necessary libraries. Here you can see all the necessary libraries we have installed actually. So after installing all the necessary libraries, we have loaded the sample data set, and then after loading the sample data set, we created a faker object for generating the fake data. Like we are generating the fake data, and then we created a list to store the data actually, and then after that we imported the pandas to create data frame. So all these steps we are step by step I'm explaining you here. So we have also plot the association rule model in 3D and manually created. So manually created. So all this actually we manually created a 3D scatter plot if model 2 has support confidence and fit column. So basically all these steps we have done in this association rule actually. So in I also want to start this one also. So here also we imported the libraries first, as in all the whatever the required libraries we have installed here also. So we generated the synthetic transaction data actually. So here we also this is also we have faker object we have used to generate the fake data. Here we are plotting the model, visualizing the rules in 3D, and we created a 3D scatter plot using matplotlib if the columns antecedent support like leverage and conviction exist in the model's rule data frame. So each point if the plot represents an association rule. So here handle cases, handling the cases without essential columns. So if the required columns are not present in the model's output, a message indicating this will be printed. So yeah, so all here this all this you can see here. So all this we have done in this collab basically. So now I'm starting with this time series forecasting collab. So firstly, we are importing the necessary libraries. So we are in this below one, we are we are loading the gold data set in my case, and then we are taking only the first 200 data points actually, and then we are printing the column names. We are now setting up the forecasting experiment actually. So forecasting horizon of 10 days, we are taking into consideration, we are creating a ts foresting experiment object actually. So all this we are performing here we are printing the type of the object. So this is the step by step explanation I am giving actually. Now we are setting up the experiment using the setup method actually. So and I, we are now we are now checking the statistical properties of the data set. We have below we will come here we will comparing the different models and select the best one. So we are also plotting the forecast of the best model. We are predicting using the best model. So we are showing the first few rows of the prediction. So yeah, so like all these steps we are doing. Then like we are saving the best model pipeline, so we have also named this like the gold pipeline. So now that like we are loading the same model pipeline, and then like we are printing the loaded model pipeline. So yeah, all this like we are doing in this collab. So yeah, I'm going to start with the grad.io demos actually. Now I'm starting actually with Grad.io. So like we have created two interactive web apps using Grad.io where users can put data and see model prediction the real time. So basically like we have installed the necessary libraries and installed PyCaret here. So and we have I use the diabetes data set here. So we are loading the data set, and then we have set up the PyCaret environment actually. And then like we created a decision tree model actually. And after creating the decision tree model, like we created a deployment application. So here you can see this model, it created a user interface web application. So where here you can see we can give all the inputs and we can get output here. So similarly, like I also created a second demo for that. So all like here I use the different data set. Like in first demo I use the diabetes data set, and here I use the juice data set. And here we can see all the beautiful web application. So here it's inputs, inputs we can give. So accordingly it will give the output. So basically this is all the collabs I covered. I explained all the codes here. So in all these collabs I shared in the GitHub. You can find all the collabs in the my GitHub. I'm sharing the link of my GitHub repository in my assignment portal. So there you can access my all my collabs. Thank you.